So good afternoon, everyone. Thank you for joining our RCMAR method series. I'm Kenrick Duru, one of the co-leads of the RCMAR, along with Carol Mangione, and we're very excited to have one of our own RCMAR faculty speaking today. And this is Dr. Ron Hayes, I think well known to most of us, really a true international expert in his field, professor of medicine, psychometrics, who will be speaking on 2 self-report questions about glare.
Okay, so I'll put this back up just in case people have a camera that works and they want to point to this or take a picture of it, or this will come back up at the end, and you'll also get an email if you need it. And you could also click on the link at the top, but I don't think you can click right now, so it probably doesn't help you. Okay, I'll go ahead and start. Please ask questions as I go along. Just make sure you interrupt me enough so I can hear you. This is just a standard disclaimer, but mainly that anything that's in here that's wrong is mine. There's colleagues that worked on data and other papers that are not part of this analysis, so they're not responsible for any of that. I'm just going to start with the idea of laser eye surgery. It's one type of surgery that's used to improve visual acuity for nearsightedness, farsightedness, and astigmatism. And like any surgery, there are possible complications. And some of those complications include glare, especially halos, as one of those things that could happen as a result of surgery. This is just one example of a study that was done to look at rates of glare that were reported associated with surgery. And this is a long time ago. This was published 18 years ago. It's just an abstract that appeared in the Investigative Ophthalmology and Vision Science Journal. And it was a small sample of 147 patients. And at baseline of the study, 38% reported glare. And then 3 months after LASIK, it went up to 43%. So some people might start off wondering, well, should people have glare at all at the start of LASIK or not? And I think the expectation is that you're going to have some level of glare, I don't know the exact amount, but having some level of glare, maybe not so different from what's reported here, would be your prior expectation. So glare is caused by bright lights that block vision. And I think a lot of us are familiar with glare, but this picture shows 4 types of glare referred to, as you can see, as snowballs, halos, starburst, and streaks. So those are 4 forms of glare, but we could also ask about glare more generally. There's also some distinction made between discomfort glare, which is the sensation of annoyance in our eyes when we see a bright light, versus disability glare, which refers to visual impairment caused by the scattering of light entering our eyes. So sometimes you'll see that distinction reported. I'm not actually going to focus on that today, but you'll see that in the literature. And there are a variety of objective clinical measures of glare, and I say objective in parentheses. But this is one example, the brightness acuity test, or BAT. It's used to evaluate the extent to which vision worsens when you vary the levels of lighting that mimic different conditions such as direct sunlight, and the extent to which when you do that, you see an effect on vision is an indicator of the impact of glare. There are also patient-reported measures of glare. And the PROW project, which is patient-reported outcomes with LASIK project, is one example where patient reports about eye symptoms, including glare, were collected. The lead person on this project was Dr. Edelman from the FDA Center for Devices and Radiological Health. People from UCLA who worked on the PROW study were myself, Karen Spritzer, and Steve Reese in psychology. And 3 years ago, 2 papers from the project were published in JAMA Ophthalmology. I note those 2 here. So one of those was on the psychometric properties of the questionnaire, and the other was reporting on symptoms and satisfaction. Okay, so the PROW project, which is going to be the basis of what I'm going to report in a little bit, was a longitudinal observational study that had over 500 patients who were followed over time in the study before they had surgery, 1 month after, and then 3 months after the LASIK surgery. And there were actually 2 parallel sub-studies. So PROW-1 focused on active duty Navy personnel, and PROW-2 was a 5-center study of civilians. All study participants completed questionnaires over the internet in this particular study. And if you look at the characteristics of PROW-1 and PROW-2, given what I said about PROW-1, it's not surprising that the majority were men, 80% were men, whereas PROW-2 was more balanced. It was 54% women. But PROW-1 was more diverse than PROW-2 in terms of race, ethnicity. The PROW studies eligibility required English language completion of the survey by adults who were considered to be good candidates for LASIK. And you can see that PROW-1 had a target for refraction of bilateral emmetropia or slight hyperopia. And PROW-2 had a similar target, but there was an oversampling of higher refractive errors. So the majority of the people fell between -7 and 1.25 diopters, but you had some people who were at the extremes in terms of near and farsightedness. So an interesting aside was that there was an article published in the New York Times 2 years ago that referred to complications of LASIK, because there's a big subgroup of people who think that the FDA should not allow LASIK surgery because they've had terrible results, like blindness. And so there's this huge group, and there's sometimes literature that refers to the problems or complications of LASIK. So there was this article, and they incorrectly referred to the PROW study as a clinical trial. It's just an observational study, but they turned out to incorrectly refer to it this way. So that's just an aside. So getting into the specifics of today, one of the questions in PROW used to assess glare was this one. And so one of the things we did when we were developing the survey or questionnaire was we had some new questions that I'll be talking about, but we also wanted to use some old measures that had existed for a while, or legacy measures. And this particular one, this one item, is part of the National Eye Institute Refractive Error Quality of Life instrument that was published 17 years ago. So you can see at the bottom that Karen Spritzer, myself, and Carol were authors on this paper in ophthalmology 17 years ago. Now, this particular question was item number 33 on the baseline or preoperative questionnaire, and then on post-surgery questionnaires, it was item 27. So it was somewhere around 20% of the way through the questionnaire. There were a lot of questions in these surveys. Several new items were developed, though, in this project to assess visual symptoms, and those symptoms were glare, starburst, halos, and double images. So they were loaded on glare-related symptoms. We also assessed double images. And the way these were set up for respondents were, prior to seeing the actual question, they were shown a picture like this that you see here, and a definition so we could help standardize what they were being asked about. And what the picture here shows is 3 panels with increasing amounts of glare. And this is the actual picture and definition that was used in the study to refer to glare. And as you can see, we're referring to glare generally here with this particular set. So following the definition and the picture, this question is what was asked. So people were asked in the last 7 days, have you noticed any glare? And here you see they have a response set of options, four different possibilities. So this is different from the NEI item. It's different from the NEI item in several ways. So one is just the item stem itself. It's not worded exactly the same. The response options are obviously different. And when it's asked in the questionnaire varies because you can't ask it at exactly the same place. Turns out that this is item 50 in the baseline questionnaire, which is 31% of the way through. And in the follow-up questionnaires, it was about 36% of the way through. So this question always occurred after the NEI question that was asked, asking, putatively about the same thing. So I will stop right here before I go to a little data just to make sure. Does anyone have any questions so far? Sounds like not. Okay. So now we're going to look at data. What did the data show? So here we're looking at all available baseline data, not just those who were in the analytics sample, because we had an analytics sample and it required that they have completed at least one follow-up questionnaire as well as the baseline questionnaire. For this purpose, I'm just going to use all the available baseline data because there's no reason not to do that. So what we see in looking at this crosstab, if we look at the columns, we find that going down that last column, that 28% of the people at baseline reported experiencing glare in the last 7 days. And so this was the NEI item that's asked that way. Have you experienced glare in the last 7 days? On that legacy item, we get 28% of the people who say they had glare. So that's not too far away from that one example study that I referred to earlier. Now when we look at the rows, we can look now at the new item that has the picture and the definition before they're asked a question. So this is the item that was developed for the study. And we see that a lot more people now reported noticing any glare in the last 7 days on this picture question. It's 39% of this sample. So there's already something that looks different about what we're getting in our reports back, depending on how we ask the question. So as you're looking at this crosstab, it may be natural for you to wonder about the lack of agreement we're seeing between reports of glare for the two items if we're measuring the same thing. And if you then start to kind of dig down into the table, you see that there's, just looking at the diagonal from top left to bottom right, that there's 76% agreement overall. And then if you look down at the bottom part of this, I looked at kappa agreement and it's 0.46. The correlation between the two items is always going to give a similar estimate to kappa when you have dichotomous items. And here, that correlation is 0.48. A lot of times it's going to be exactly the same, or it will be very, very similar like it is here. So with that data, you might say, okay, well, how good is the agreement? You might think, well, it's lower than I might expect. And so how does that 0.46 look? Well, there are some guidelines that have been out there for a while. One of these is the first one here, Fleiss, 1981. It would suggest that that 0.46 is fair agreement. And then if you look at another guideline, Landis and Koch, they classify this as moderate agreement. So given we're asking about the same thing with pretty much like a yes-no sort of assessment, this doesn't necessarily come across as looking like very good agreement when you see those two questions cross-tab this way. To give a different perspective on the agreement that we see with these two glare items, I'm showing here a cross-tab of the same item that has been administered twice in the same instrument. And the measure that's being used here, this is a whole other set of data, but this is real data. And the measure is the Minnesota Multiphasic Personality Inventory. And this long inventory includes over 500 true-false questions. And it was once the most widely used measure in psychology and was administered every year to incoming college freshmen at the University of Minnesota. But Interestingly, a few of the items in this measure are administered twice. And this is one of the items that's administered twice in this one assessment. And here you see that some people are going to change from true to false or from false to true when they answer whether they are more sensitive than other people. When that's asked at item number 317 versus at item 362. And you can do the same kind of analysis of agreement as we did with the glare item, and you see kappa here is 0.74. The correlation between the two items is 0.75, and there's 88% agreement when you look at the diagonals. And I have the citation for where we have analyzed this data. There's a lot more we did, but this is one of the things that was in that data set. So we're asking exactly the same question twice, and we're getting better agreement than when we asked variant of the same idea on glare. So that we can look again to see, well, how good is 0.74 kappa? According to Fleiss, it would be good. So it's a category up from what we saw with glare. And it's substantial according to Landis and Koch. So it's also another category up from what we saw for glare for what Landis and Koch have said. Okay. So you might be thinking now, well, the two glare items are pretty unreliable. So now we can look a little bit more to say, well, how good is that agreement or how bad is it? So this slide is showing the reliability of the glare items, that the reliability of the glare items is actually like the reliability of a lot of single items we use in multi-item scales all the time. So what I've shown is that if you have the middle category is the scale reliability you've actually observed, and I'm varying it between 0.9 and 0.7. 0.7 is a reliability that we want to get as a minimum level for group level or research purposes. 0.90 is a reliability we'd like to have for individual assessment as a minimum threshold. And I'm saying that, well, what if we had that level of reliability that varies here, and the number of scale items is ranging from 5 to 15. So seeing something like a reliability of 0.90, the second row for 10 questions, or the final row there, would not be that unusual. In fact, it would probably be pretty good for a lot of the multi-item scales we use. That's something like the SF36 physical function scale. But if that's what you actually get, then that's what this is saying in the first column, is that the average item reliability would be 0.47 in order for you to end up with a scale reliability of 0.90 when you have 10 questions. So this is just using the Spearman-Brown prophecy formula. Similarly, if your reliability was not so high, not 0.90, but 0.80, which would be, you know, very nice actually for research purposes for a scale, and you had 5 questions it took you to get to that 0.80 reliability, then the average item reliability would be 0.44. So the reliability that we're seeing for our items based on that kappa of 0.46 is comparable to these situations that I've shown here, the second and fourth row as highlighted in yellow. So actually what we're seeing is not that atypical when you have 2 questions that are supposedly measuring the same thing. So it may not be as bad as one might think otherwise. So given what we've seen so far, you might consider not just using individual items, but creating a simple summated 2-item glare scale that would have values ranging between 0 and 2. Where 0 would mean they reported no glare on either question, and 2 would mean they reported glare on both questions. So that's what these columns are showing, the NEI versus the picture item. What is the response you're getting? And of course, I'm just pooling together all the yes responses for the new question because it has 4 response categories. So we're just simplifying it to make it two dichotomous items. And then if you said yes to one item, but not to the other, you'd get a score of 1. So that's what you would do in a simple summated scale that has 2 questions, each that are scored 0 and 1. You would have a range between 0 and 2, and it would look like this. So if you did that, and then you estimated the reliability using Cronbach's coefficient alpha for this 2-item scale, you would get 0.64 is the reliability. And if you then looked at rules of thumb for that, as I already said, 0.70 is the minimum you would like to have for a scale if you're going to use it for research purposes, which is what we're doing here. And this 0.64 is below that. So it's not as reliable as you would like if you're going to be using it for research purposes, but it isn't horrible either. Although some other criteria that I referred to here would call it questionable, because they're calling 0.70 the start of acceptable, and therefore anything below that is going to be questionable. But at least they're not calling it poor or unacceptable. And this formula, the formula for Cronbach's alpha is circled here just for people who want to investigate it later, in case you have no idea what it entails. It's based on a analysis of variance where you separate between people variance versus an estimate of error, which is an interaction between the way people respond to different items. That's the EMS term. And I'm just going to leave that for people who want to look at that later if they need to. Okay, what did I do? Did I skip? Sorry, yeah, okay. So I'm at the point of saying, well, we can make a 2-item scale with scored 0, 1, 2, but before doing that, I wanted to make sure that there wasn't possibly some support for scoring a yes to the NEI item differently than a yes to the picture item. Because it might be that a response of yes to one item indicates that you have more glare than a yes to the other item. With a simple summated score, we're just assuming they're equivalent. Each yes is equal, but I wasn't sure, and I thought, well, maybe I'll get a little more information by scoring them a little differently and scoring at 0, 1, 2, 3 and adding, one more category, because maybe a yes to one item means more glare than a yes to the other. So what I did here was the columns show you the 4 groups that I was considering. And I started with the idea that, well, maybe a yes on the picture item is more glare than a yes on the NEI item. So I kind of rank ordered them this way from A, B, C, D, where A is no glare at all, D is the most glare because you say yes to both, and then B and C are in between. It doesn't really matter whether I put B or C first, except this was sort of my hypothesis going in. But what I then look at on the rows is, what are the mean scores on eye symptom scales and on satisfaction with vision for people in each of these 4 categories? And the superscripts that are shown in each row are telling me whether or not the subgroups in the columns differ significantly from one another or not. If the subgroups share a subgroup and a superscript, in a row, then they do not differ. So I've highlighted the middle categories B and C because that's what I'm really focused on. I want to know if there's any difference in what this means about glare, assuming that glare should be associated with some other related measures. And what I see is that those B and C columns never differ significantly. So it doesn't seem to matter whether you say yes on one or yes on the other. You should treat them as being equivalent. So therefore, what we decided to do with a simple summated scoring 0, 1, 2 seems to be appropriate. There seems to be no support for scoring the individual yes responses differently. Okay, so next, now we're going to look at the associations, and that's correlations and regression coefficients, of the simple summated glare scale with other measures in the questionnaire. And so we did I did various analyses, and this is kind of the bottom line. I didn't just look at these. I looked at some other measures, but these are kind of the ones that seem to be significant either in 0 order or in a regression model. So what this shows is the glare scale is associated with other symptoms in the expected direction. So that's not too surprisingly, so if you have halos, you're going to tend to have glare. If you have starburst, you're going to have glare. And don't worry about the signs. The signs are correct. It just depends on the direction of scoring things. And it shows that, and it also shows that the strongest associations of this two item glare scale are with halos, starburst, and dry eye symptoms. And it's not too surprising that the largest zero order correlation with the glare scale is halos, since halos is a form of glare. And second, and very close to that, is starburst, because that's another form of glare. So you're really getting a similar thing there. And dry eye is then next. That's the ocular surface disease index. And that's also not surprising, because dry eyes often go with these kind of symptoms like glare symptoms. So the correlations are shown first, and then in parentheses, I mean, the product moment correlations are outside of parentheses. They're shown first, and then Spearman correlations are shown in parentheses, just so you see that it doesn't matter. Basically, you get the same result. And then when you look at a regression equation predicting the glare scale, and I did that in a lot of ways, assuming OLS, and this is the OLS result, but I also looked at ordinal logit and so on, and it was consistent. You see that halos has the largest standardized beta, and then starburst and dry eye symptoms are next. And then we actually have optimism comes out as being related. And then the other three things that are here, double images, satisfaction with vision, and anxiety, depressive symptoms, become non-significant in the multivariate model. But overall, the pattern of associations here makes sense. And in the multivariate model, the adjusted R-squared is 35% of the variance. So whatever this two-item scale is, it seems to at least make some sense in terms of its relationship to other things. So far, this is a summary of what we found. The glare items correlate as highly with one another as typical items in multi-item scales that we look at all the time. Now, we do have a problem because we only have two items. We'd like to have a lot more, because the two items only produce a reliability of 0.64. We would really need more items to get reliability that we'd feel comfortable with for group comparisons. But at least the items themselves seem to be not much different from other items that we use all the time. And that reporting glare on neither item is suggesting no glare at all. If you report glare on only one of the items, that's some intermediate level of glare. And then if you report glare consistently on both items, that indicates the most glare. And so as we just saw, the sum of the two glare items is most strongly associated with halos and starburst, two other indicators of glare, only more specific indicators. So before I go on, I want to again stop and see if there are any questions.
Nope.
Okay, just want to be sure. Okay, now just a few more results. Recall that there was a lot more glare on the picture item than the NEI legacy item at baseline. And so you can see here the NEI item had 27% at baseline, the picture item 38% at baseline. But now we're looking also at the 3-month post-surgery follow-up. And when we just look at that column, or those two columns for the NEI item and for the picture item, we're seeing very similar reports of glare. So you see 27% on the NEI item and 25% on the picture item. So even though you have these baseline differences at the 3-month follow-up post-surgery, they're very similar. And the change from the NEI item over time from baseline to 3 months was not significant. It's basically 27% both time points. But the change on the picture item, the new item that we developed with the picture and the definition, was significant. That glare went down significantly from baseline to 3 months later. So that's an interesting difference. Now, when we look now at the 1 month post-surgery, we see that reports of glare on the NEI item compared to baseline went way up. They went from 27% to 42%. And this is in comparison to an actual slight decrease in reports on the picture item. So the picture item was higher at baseline, 38%, then it went down to 34% at 1 month post-surgery. And now we have all the data shown here. And the overall summary is that we're getting some differences just on these two items, even though the items are positively correlated and they seem to be relatively reliable, at least for single items. We still see a difference here. So the NEI legacy item, we have baseline to 1 month, we have a significant increase. So if you were to conclude what happened to glare as a result of LASIK surgery, using that one item, you would say, well, it got worse, went up by 15%. But if you looked at the picture item, you would say from baseline to 1 month, there's basically no change. And if anything, it went down, but it wasn't a significant decrease. And then if you looked from baseline to 3 months on the picture item, you would say that it did go down because it went down by 13%, 13 percentage points, that is. So there was a significant decrease. So just looking at these two items now, you're going to come to different conclusions about what happened post-baseline. So now, if we look just at baseline to 1 month to see what's happening and what's going on with the differences in reports, we see that there's a decrease in reports of no glare to both items from baseline to 1 month later, but an increase in reports of glare to both items. So in the extremes, we see different things. We see a decrease of consistent reports of no to both items and an increase in reports of yes to both items. So those are the first two rows. The first row is the no to both. The second row is yes to both. So we've got some funny thing going on there. In addition, the number of people reporting glare only on the NEI item, the legacy item, went up while the number reporting glare on the picture item went down. So we have just a lot of strange things in terms of differences and change over time depending on which item we're looking at, and the pattern of the two items together differs. So it's pretty confusing situation, but what do we make of all this? In retrospect, well, I should go back and say that in those articles that were reported 3 years ago, the NEI item was just there as a legacy item, a legacy measure. And there are other legacy measures too, just to have some continuity with the past. The idea was the new items were going to be better. But the results were reported for the NEI item as well as for the new items, just separately. So in retrospect now, if I look at this, I might say, well, maybe I should be reporting the 2-item glare scale, even though it's not as reliable as I'd like. I'd like to have more items than that. Maybe I should report it and score it something like 0, 1, and 2. You know, so 0 is neither item did you report glare. 1 is one of the items you report glare, and 2 is both items you report glare. So that would be the simple summated scale score. And then I could estimate the glare by changing that 0, 1, 2 and make it 0, 0.5, and 1. So I could give a half point if you pick glare on one item but not the other. And if I do that, then I would say, well, maybe the best estimate of glare from what we've got is baseline 33%, then it goes up to at 1 month to 39%, and then it goes back down to 25%. So that might be actually a pretty reasonable thing to do. You could also just dichotomize that set of 2 items and not give half credit, just, you know, say zero response versus a 1 or a 2. So you could just dichotomize it. Then any report of glare would get counted as glare, and the amount of glare would be a lot higher than it would at all time points, but it would be the same pattern. It would be 45% at baseline, then it'd go up to 51% at 1 month, and then it would go back down at 3 months to 33%. So either of those might be a reasonable approach now in terms of trying to get a handle on what really happened to glare over time. I have a slight preference, I think, for the first, just because it seems like it's a more reasonable estimate, but someone else may feel differently about that. But we're still, no matter what, we're going to wonder why at the 1 month follow-up, when glare was only endorsed on one item, do we get these different results? Like with the NEI item, it went up, you know, from 7% at baseline to 17%, and overall rates of glare went up by 15 percentage points, whereas on the picture glare item, which started higher, it went from 18% to 9% who reported glare on that item. And overall glare was estimated to go down from 39% to 34% or so overall. So it's still puzzling. But one thing we could probably do is at least try to do cognitive interviews with people on these two items. I'm not sure exactly what else. Some other people may have some ideas, but clearly we'd want to follow up and figure out why is this happening. The end result might be that we'd want to have the solution that combines the two items together. Someone else might say, well, the new, you know, they might say the new item is better, so you can ignore the legacy item, but I think that would be a hard argument to make. So I think that's where we're left with this, and I'm just going to open it up for questions. Along with some links.
Great, thanks, Ron. So we're open. I think people can either ask, we have a small enough group, or if you want, you could put it in the chat, but either way is fine. And this is, please, as if you weren't on in the beginning, we're trying to get evaluations done right away. So you can take your camera, take a picture of the QR, or hold your phone up to the QR and be able to get the evaluation.
Yeah, I'm not looking at the chat, but I could do that.
Well, I have a question, Ron, actually, to start. So, you know, I think it looked like the language you were using was pretty easily understood, but I always think of pictures as being easier for people with, you know, very low literacy. I think, do you think that differences in literacy could have kind of explained some of the different responses on the two items, or is that, you think, less?
Well, the hypothesis was that, you know, this definition would standardize things and seeing a picture would standardize things. So our bias was that this is better approach, but we didn't expect to see the differences. You know, we might expect to get slight differences in estimate and maybe less missing data or clearer data, but we just, you know, it's so weird, the interaction kind of effects we saw, that we didn't expect that. So yeah, my bias would be maybe this is better. Although it's a little more complicated here in the response options. You know, the fact that we throw in whether when you're wearing or not wearing contact lenses or correction, you know, that might make it a little more difficult, that part of it. But yeah, it's hard to know. That's why some cognitive interviews and follow-up, you know, we might be able to see, does it work better for one subgroup or another, especially those with lower literacy. But it's really a puzzle now. I'm not sure. I've asked ophthalmologists, you know, is there something about experienced glare versus noticed glare that makes a difference? But, you know, if it was consistently higher or consistently lower, then I would have a better hypothesis. But I haven't gotten any great suggestions yet, but hopefully someone does. You know, Linda Bork, a long time ago, about 3 years ago, when we first started looking at this, was making some suggestions, but they didn't turn out, in my opinion, to be on the right track. So I asked her a long time ago, and then I've been trying to ask people since. So it does kind of, though, emphasize the importance of not just asking a single question, because, you know, and in this case, it would have been nice even to ask more.
Yeah, because you're right. Because, you know, I wonder, you know, when you have the picture, like, is that now you have both, you now have another sort of cue toward glare that So someone might say, oh yeah, actually you do have some glare. I didn't think about it before, something like that. But that's just our impression. Like you said, it doesn't really, just because we have that impression and we feel like that may be the reason that doesn't, that and or literacy itself, we just don't know. So it'd be interesting to try to go back and try to ascertain exactly why they answered that differently.
Yeah, and some people would say that's not necessarily the best. You know, whenever you do a picture or anything, you could do something that doesn't work for people. Now, we did do cognitive interviews and stuff here, and supposedly, you know, but I don't believe that you always cover every base with your cognitive interviews if you haven't done a ton of them.
Right.
And we did some. But this question right here, I went back to this one. This is actually a newer version of asking about glare. So
Okay.
this is, I don't know if this is better or not, but this is from the Academy of Ophthalmology in another project where we're looking at people with cataracts who get surgery and then intraocular lens. And this was a consensus where, well, let's say glare explicitly is snowballs, halos, starburst, or streaks, and show pictures of all of them. And prior to this, they actually see each of these individually. So one of the things I'm doing with this other data is looking at, you know, like on the separate questions about snowball, halos, and then there's a question about starburst, or streaks. It's not 4 questions, but it actually turns out to be 3 specific ones. Then say, if they said yes to any of those, how does that compare to what they said here on this global glare kind of question?
If
And
someone,
I'm getting pretty good agreement there. I think it's a little better than what we saw here, but still, there's still some disagreement even there. And the estimates there in that particular situation are like 82% glare is reported at baseline before surgery in people that have cataracts.
yeah, because I'm thinking if I had maybe halos or starburst and someone asked me about glare, I might not think I have glare.
Right.
So until I saw that and I said, oh, that qualifies as glare. Oh, okay.
Yeah. So that's the idea, I think. And then, you know, glare is a concept that I don't think, you know, people have an idea about, but they don't, they don't necessarily think of these things specifically as being glare. They may put it in a different category, like you just said.
Ron, this is Gary. You're actually not showing them a picture and say, do you recognize glare? You're showing them a picture and say, here's what glare is. And then you're asking them to recall if they've had glare, right?
Right. Now, I should say before you go on, I want you to ask the question, but we did do some preliminary work where we showed pictures of different things and asked them to say what it was. And then it followed up and said, okay, you know, explicitly, is this, is this halos? Is this, you know, whatever? And so there was some upfront work to try to make the pictures better. But, you know, again, I don't think it wasn't complete. You know, you're not 100% sure.
But what I guess what I'm getting at is you're trying to get them to match a construct in their heads with something that has occurred in the past. So it's not a direct comparison. And what you showed them there, what we're all seeing represents what we see if we have corrected eyesight. Do you really understand what it looks like if they don't, if they do have a problem? So it may turn out that your glare makes sense right now for people who have decent eyesight. You can distinguish between those 3 pictures, but it might be harder to distinguish if you have a glare problem yourself. Does that make sense?
Yeah, but I don't know, follow up with what you just said, to distinguish, but no glare from any glare or level of severity?
I'm thinking it's a level issue. But it seems this is the same sort of problem I think we run into with pain. Pain is an inside sense, and we're asking people to take that inside sense and translate it into a construct that is shared, which is an outside construct. That's a really hard task. How do you correct for that psychometrically?
Yeah, that's the problem, is that this concept is difficult to get across and get commonality on. So I agree with you that, I'm trying to figure out whether in this case, let's see, it's probably better to go to the end. I just wanted to, the most puzzling thing is this. There's so much going on, but like you said, they're thinking back in the past, and they see a picture, maybe that makes it more difficult, to match up to what really happened in the past. But plus in the study, they see it the first time at baseline, and then they're more familiar the second time. And there's also the interaction of when they see the first item versus the second, is that having some effect? So if we randomize the order in the future, would that make a difference? There's all kinds of things going on, basically, but it's, no matter what, it's hard to get across the idea, and we're just trying to do a better job with pictures. But, I don't know that, and there's no perfectly right answer. People aren't going to say, yeah, the glare should go up, although there was that suggestion in that abstract and in some other studies that might expect glare to go up. And overall, I might think, well, if I do the average of the two, that's what I'm going to say, at 1 month, and then go back down. So it would be great if we knew for sure a situation where here, this is what glare should be, or this is the change that should happen. That would help us some to know which one of these is right, if we could even say that. Is that making sense, Gary, or you're still getting it?
In a weird sense, you almost need to have real situations. So take those 4 glare pictures of your starburst, et cetera, and you actually have them in a situation where they're looking at that phenomena in real time. And then you go, okay, here are 4 pictures. What'd you see?
Yeah, that would be great.
That gives you a little more objectivity because it's linked to that, but at least it's real time.
Yeah, the other thing would be if you could use these clinical measures, but I don't know if Carol's on, but I don't think these are very highly regarded. I believe she said that something like this was designed to be able to get, I think, Medicare reimbursement when you couldn't show glare in other ways. So it isn't like these are gold standards, these, clinical measures, but if you had one, that would help as well. And I don't think Carol's on.
So Ron, looks like you also have a question in the chat, if you can take a look at that.
I have to kind of, let's see if I can bring that up. Let's see.
I was just saying, you also have different types of glare in the 4 pictures.
Yeah.
Halo, starburst, etc.
Yeah, now that, just to make that clear, this one is not, where was it? Sorry. I should have said that too, because this is actually not used in the study where the data was presented. I should have said that when I first got here. This is the new study that's of cataracts and intraocular lens. So this is a later version of what we were doing now to try to get an idea of using pictures. But, first people in this new study, they see snowballs, which is a small picture here. It's a full, a bigger picture, and it just refers to that. And then they see halos separately in a separate question, and then they see starburst and streaks, and that actually gets combined together, the one question, starburst or streaks. And later they then come to this, glare. So this is more an attempt to say, yeah, this is the pieces of glare, there might be all these different types. And now tell us, did you see glare at all, basically? But in the study that I presented it for here, this Prowl study, this was all they saw. There were other symptoms like, but we just said glare by itself like this. We didn't say glare as starburst or snowballs.
Thanks.
Sure.
Hi, this is Juanita. Can you hear me?
Yes.
I know I may have missed some of what you said. In regards to age, what is the age of the participants?
Well, they're all adults. Let me see if did I report? I thought I reported, but where is it? No, it had to be back there. Sorry. There's the range. So So it was 21 to 52 in Prowl 1, an average of 27, or the median. And then in Prowl 2, median of 30, range 21 to 57. So the oldest person was 57.
Yes, because when I look at your photograph, and I never thought about your vision in this aspect of the way you have the pictures for the snowball and halo and different, the 4 different perspectives. Because I know when I'm driving, because me, I don't need glasses and I don't wear glasses, but I know at nighttime, I think it must be that snowball effect or something where I do need something, because those lights that are coming from everywhere in my face really makes it complicated for me to see as well as I normally see. So I was trying to figure out if it's picture number 1, 2, 3, or 4. I think it must be a snowball thing. There's lights everywhere.
Yeah. See, there's a lot of confusion about these distinctions, I think, among people in general. It's sort of a ophthalmology jargon thing. And I think one of the reasons we wanted to try to do this here is to try to draw that distinction and see if people it would help them. If we're trying to separate them, we're trying to see, they really do want to know in this study of, cataracts and surgery for that, if people are having different kinds of symptoms. And so they're trying their hardest to make this clear, even though they're indicators of the same underlying thing of glare. They are different types, and it is tough to actually make this distinction. Most people do not walk around. I mean, halos you might, because that's sort of something that, we think of angels or whatever, so you might go, oh yeah, that's a halo. But you wouldn't necessarily think of snowball the way it is here, or even starburst. It's kind of an education process, I think, that it makes it pretty hard to be sure people are really getting it, at least from the, from what the ophthalmologists really want. Because
yeah, so do young people get, because the age ranges you said, that age range can get cataract?
Well, I'm sorry, I should have said this before, I kind of forgot. This is actually a whole different study right here that's up now. That's a more recent study that I haven't presented data on.
Yeah.
So the study where the young people are is this one. That's how glare was asked about. And I was just focused on this glare question and that one NEI question, this one. So all I'm doing here in this data is comparing 2 questions. But this is, I probably really should have said something about this. This is a whole other study. It's pretty interesting unto itself, but I didn't present any of that data here. And this is, older people because they have cataracts. This sample that we're collecting data on for this, they tend to be a lot older than the data I've presented today.
Oh, okay. Because I was getting confused.
Yeah.
I wanted to add, I think Juanita's question also gets at the difference between glare during the day and night, and you're asking at any time.
Yeah, you're right. That's another thing in the new study. We actually ask people afterwards when they experience it. There's a lot more detail in the new study. In this study, this was not distinguished. So, yeah, that's an important question. So we asked them, first of all, did it happen when they were wearing corrective lenses or not? And we also then asked them, was it during the day, was it at dusk, or was it at night? And so, is it showing now? Wait a minute. Let's see if I can bring this up. Is this visible? Are you seeing new slides?
We see the old slides.
Or you see the old ones?
Mm-hmm.
Oh, that's right, because I shared something else.
You're sharing the PowerPoint, Ron.
Yeah, but it's the old one. I want to share the new one if I can find it on here.
So go up and stop share, and then.
Well, I think if I do this, it might do it. Let me see.
Yeah.
Okay. Let's see. That's a whole other thing there. Uh-oh. Only trouble is now I can't get this. How do I get this to advance?
Try F5.
So is there a difference in an individual that has astigmatism that wears corrective lenses and one that doesn't?
Okay.
Yeah, definitely there could be. Most of the people in the study I talked about, it was nearsightedness. There was very few with astigmatism. Is this showing now?
Yes.
Oh,
We
you can
see
see
a
it.
bar chart.
Yeah.
Okay, so I'll just get to when had symptoms. This is cataract, people with cataract. So you can see most of them had the symptoms all the time when they were wearing and not wearing correction. For one thing, that's the final row. So the majority on we had all kinds of symptoms. We were a lot more here, 14 we were asking about. And then when did they have the symptoms? So here's like glare was at night primarily. You can see that's the first row. Snowballs at night, rings at night, all kinds of things that are glare-like are mainly at night. And I think that's consistent with some of the comments so far. The things that would be more day-like are floaters, double images. And, but so there we got a lot more detail. And, I think there's been improvement in what we're doing there as a result of what we learned. You also asked about severity of symptoms and so on, and how much it bothers people. There's all kinds of stuff here. So,
And I think too at nighttime, this is Juanita again, it's the some of the lights that they're allowing on these cars, you might be experiencing a little bit of everything. Those lights that are coming at you kind of crazy. It's almost like they
yeah. Well, I think glare is experienced by a lot of people when they're driving. I mean, you don't have to necessarily have any problems with your vision and you're going to have some glare. That's why I think Bob Brook was a little surprised that people who are getting LASIK surgery, that, we had the rates that we were looking at here in this study, 20 to 30% around baseline. I mean, he thought, well, you shouldn't have much glare at all, but, people are going to have glare, at least in certain circumstances. If they're having bright lights, it's just natural. Your eyes are going to feel it.